This lesson we're going to talk about system of linear equation in two variable. So we already know how to graph linear equations, one line, right? But when you have a systems, it means more than one line. And we're going to talk about particular one, which is having a two line. Let's say we have a two line that we're graphing or trying to solve the problems. There will be three different types of two line that you can have. The first one will be having one unique solutions, right? Where the one points, those two line is going to be cross each other. And that point right here, it will satisfy both line or both equations. So this is when you have one solutions. Also, you could have two line where that two line is going to be parallel to each other, where they will never meet each other, so they will have no solutions, right? And when you have no solution, we call that also inconsistent systems. You can also have infinite many solutions. Why? Because when two line is identical, same line, we call that dependent, right? So when we're solving system of linear equation in two variable, you could have two solutions, three different types of solutions. The one, it gives you one unique solutions. The other one is no solutions, and when you have many solutions. We're going to use two different methods to solve system of linear equation with two variable. First one is called substitution method. The other one is going to be elimination method, or we could say additional method. And using the example, I'm going to show you why that it is. So when we're looking at the first one, it's use a substitution method to solve. What I will do is I need to pick one of the equation out of two and solve for a variable. And probably I will pick the first equation and solve for x. That way that I will not divide and will not get fraction solutions. So if I solve for x, I just need to move the y to the other side. Once I pick one solution and solve for a variable, I'm going to replace that into the other equations. So instead of this x, I'm going to put 5 minus 3y. And then I get 5 minus 3y minus 2y equals to negative x. By doing these substitutions, I will end up getting one variable in one equation. So this equation, I can solve for variable y. Once I find the y, then I can replace it here and solve for x. So in order to solve for y, I'm going to distribute 3. That gives you 15 minus 9y minus 2y equals to negative 18. Combine the like term, you get negative 11y. Let's subtract 15 so I can have number without the variable on the other side. Will give me negative 33. Now let's divide both sides by negative 11. Your y is equals to positive 3. So once you got one solution, we're going to replace it and find your x. So your x should be 5 minus 3 times 3. That will give you 5 minus 9. Your x should be negative 4. So the points x4, y3. This point will satisfy these both equations, right? So otherwise, if you're graphing this is going to be the points where those two line is going to meet. I'm going to try one more with the substitution method. So when I'm solving B, I need to pick one equation and solve for a variable, right? And this time I'm going to pick the second equation and solve for y this time, because the constant y is 1. When I solve for y, I don't need to divide with any number to isolate y, right? So we'll be just moving x to the other side and replace that y to the first equations to create one equations with one variable. And now solve for x. I'm going to distribute -4, give you positive 16x minus 20 equals to 2. Combine the like term, I get positive 11. And then let's add 20 for both sides to put number with the variable on the other side. I get 22. Let's divide both sides by 11. My x should be 2. Once I have one solution, let's replace it in the other one to find my variable y. So I will have -4 times 2 plus 5. This makes it -8 plus 5. My y will be -3. So x is 2, y is -3. Make sure when you're writing a point, your x value always comes first before your y value, right? So this is how you're going to use substitution method. Let's try C. So I will pick first one, solve for y. I get 4 minus 2x. Replace that into the other equations. I get 3 times y, which is 4 minus 2x, equals to 6. When I open the parenthesis, I get 12 minus 6x equals to 6. When I combine the like term, this 2 is the like term, 1 is positive, 1 is negative, it cancels out each other. It means no longer have variable. I have 12 equals to 6. So when your variable disappear, you either are going to have many solutions or no solutions. When do we have no solutions? When this equal sign is holding false statements. So once variable is not there anymore, it canceled out. I have 12 equals to 6. That's not true. So not true, false statements. This will give me no solutions. No solutions mean this two line is going to be parallel line. So they will never meet each other. There will be no one points that will satisfy those two equations. What about the next one? It's already solved for y. So when we replace that here, I get 4 times 2x minus 1 equals to 4. And when I open the parenthesis, I get 8x plus 4 equals to 4. Again, variable cancel out completely, right? No more x. Then this time I have 4 is equals to 4, which this time is true statement. When equal sign holds true statements, you will have many solutions. That means that this two line is the same line, identical line. Now I'm going to solve system of linear equation using elimination method. Remember, elimination method, other word is additional method. So why is that? We're trying to eliminate one of the variable by adding two equations. So I'm trying to add these two equations to get rid of one of the variable. Here, I use the substitutions to get rid of one of the variable, right? Create an equation with one variable. Elimination means I'm going to eliminate one of the variable in order to solve the other one by adding. So in order to do that, when I add these two equations to get rid of one of the variable, let's say if I wanted to get rid of x first, by adding, if I have 2 here, I need to have -2 there. So when I'm adding, those two will get cancel out each other. So in order to do that, I need to multiply the second equation by 2. So that way I have +2, -2, and they will cancel out each other, right? So let me write that. I will just write equation 1 as it is. That's going to be 2x plus 3y equals to 1. But equation 2, I'm going to multiply by 2. That's going to give you -2x plus 2y equal -6. And when I'm adding those two equations, x completely cancel out because they're opposite. Y will be 5y. Other side will be 1 plus -6, which makes it -5. When you divide both sides by 5, my y will be -1. So if this is the exam or quiz, you should be able to use substitutions here to find your y value once you have one solutions. But because we're trying to learn elimination method, I'm going to keep working as elimination. This time I'm going to try to solve for x, right? So in order to solve x, I need to eliminate y. And it means I need to make y opposite. So I have 3 here already. And if I multiply this by -3, I will make it opposite. So when I'm adding it, it will get rid of y variable. So that means I'm going to again write equation 1 as it is. But equations 2, this time I'm going to multiply by -3. So then -1 times -3 is +3 minus 3y equal -3 times -3 is +9. Let's add it. That will give you 5x, no more y variable, that will be 10. Divide both sides by 5, your x is 2. So your solution here, your x is going to be 2, y will be -1. Okay, let me try one more. So when we're looking at these two equations, let's see, I'd be able to get rid of x by multiplying the first equation by -2. That's easier than trying to get rid of y, right? Because in order to make commons between 7 and 5, I probably need to multiply both terms. This by 5, this by 7, right? And sign is already opposite. So in order to solve for x, that's what I need to do. But in order to solve y, I can get rid of this by just multiplying one equations. So let me do that first. So I'm going to do equations 1 multiply by -2. So I will make it -6, right? That will give me -6x plus 14y equal -2. And then just equation 2 as it is 6x plus 5y equal -17. Add this 2, no more x. Your y is 19. This gives you -19. So divide both sides by 19. I get y is equals to 1. Let's try elimination method to solve x. This time I'm going to multiply the equation 1 by 5 and equations 2 by 7 then, right? So equation 1 multiplied by 5, I get 3 times 5, 7 times 5, 1 times 5, right? Equation 2 multiplied by 7, 42x. 5 times 7 is 35. Negative 17 times 7, right? That's going to be negative 119. When I add this, no more variable y, that gives you 57. This is negative 114. When I divide both sides by 57, I get negative 2. So here, this problem solution is going to be negative 2 and negative 1. Let's try example 3. This time, we're going to use the solving system of linear equation method to do the word problem. The example 3 is asking, hospital use of 15% bleach solutions to disinfect the quarantine area. How much 6% bleach solution must be mixed with 18% bleach solutions to make 50 liters of 15% bleach solutions, right? So whenever I see the word problem, what I wanted to do is, you don't have to understand 100%, right? The first thing I wanted to figure out is giving a variable for what we're looking for. So it's a how much 6% bleach solution must be mixed with 18% bleach solutions. So they're asking you to find out the amount of 6% bleach solutions. How much, right? So that's going to be your x. But also you need to figure out how much 18% of bleach solutions you're going to use it, right? So that will be y. So with that, I'm going to use the variable, and I know what I'm looking for. Using that information now, I'm trying to figure out what other information I have, and I will use variable x and y to write down all those information I have. So look like I have 6% bleach solutions and 18% bleach solutions to create 15% bleach solutions, right? And then we need to know if we have amounts. Is that amounts given, right? So 6% bleach solution amount is going to be x. 18% is going to be y that I'm looking for. 15%, we're going to try to make 50 liters of it, right? That's what it says, 50 liter of 15% is what we're trying to make. What other information do we know? So from what's given here, if we multiply these two, we will be able to get pure amounts. So if you wanted to write that down also, finding a pure amounts, right? You will multiply those two. So it will be 0.06 times x, and this is going to be 0.18 times y will be the pure bleach solutions, right? And this is going to be 0.15 times 50. And we know if we add this amount, it should be equals to 50 liters. So in other words, if you're doing x amounts plus y amount, this should be 50. So if you wanted to only use one variable by replacing y with x, y will be equals to 50 minus x. It means this one right here should be able to rewrite it as 0.18 times 50 minus x, right? And that's going to be your equations. Equals to is right there, so that will be equations. So if I wanted to write that on the bottom, just the equation itself, it's saying 0.06x plus 0.18 times 50 minus x should be equals to 0.15 times 50. Here I created one equation with one variable, so I should be able to solve for x and then replace it here, find your y variable. So let's find for x first, and I see all this decimal, so let's multiply by 100 to get rid of decimal. It will give me 6x plus 18 times 50 minus x equal 15 times 50. Let's open the parenthesis. So 18 times 50, you get 900 minus 18x equals to 15 times 50 will be 750. Combine the like term, you get negative 12x. Let's do subtract by 900. So you can put number without the variable on the other side will be minus 150. When you divide both sides by negative 12 to isolate x, you get 12.5. So when x is 12.5, use the substitutions to find y. You get 50 minus 12.5. Your y will be 37.5. So you will say 12.5. So you will say 12.5 liter of 6% bleach solutions and 37.5 liter of 18% bleach solution is what you're going to require in order to create 50 liter of 15% bleach solutions. Always trying to create a variable first, right? Give the variable for what you're looking for, and then using that information to create what you have, what information you have, right? And using that to create an equation and make it one variable and solve, right? And use substitutions to finish it or eliminations, right? Let's try another one, just one more. This time example 4. Let's say example 4 is asking a riverboat travel upstream against the current in a Mississippi River take 3 hours to travel 24 miles. The return trip downstream with the currents take only 2 hours. Find the speed of the boat in still water and the speed of current. So again, by reading this problem, I understand two informations. The first one is what we're looking for, right? Find the speed of boats in still water will be x. And speed of currents, I'm going to say, because it's currents, I'm going to use the letter C. So we're looking for x and c this time. What else do we know? They're talking about speed and distance and time. So I know somehow I'm going to use the formula for distance. D is equals to rate times time. In order to find the distance, you're going to multiply rate, speed, with times, right? So we need to have, in order to use all this formula and information, we need to have distance, rate, and time informations. So we have two cases. The one, it goes up the stream. The other one is going down the stream. Let's see, for the both case, I wanted to see if I can find distance rate and time. Whatever is missing, that's what I'm going to solve for. But I wanted to see what information I have from these formulas because formula is the one that gives you equations usually, right? So let's see what information I have. So for the upstream, distance is going to be, it's a Mississippi River take 3 hours to travel 24. That's going up against current, right? So it will be 3 hour. Travel distance is 24 mile. Rate is something that you don't know. And we know that its speed of the boats in still water is x. Speed of the current is c. So your rate should be going against stream because you're going up will be your speed minus the current. Downstream, you're going the same links going down for 2 hours, so it will be 24 mile. Distance will be the same. Time is going to be different, right? This time going down the stream, so your speed of the boats in still water is x, but because the current is helping you, you will add c this time, right? So with that, I should be able to create two equations, right? It's a distance equals to rate times. So it will be x minus c times 3. I could do 3 times x minus c just to make it look easy to see, right? Same thing here. It will be 24 equals to 2 times x plus c this time. And what we can do here is I could probably use the elimination method to get rid of one of the variable. So in order to do that, let me divide this by this first equation by 3. Then I get 8 equals to 3 disappear because I'm dividing both sides by 3. And I get x minus c remains. Second equation, I'm going to divide by 2. Then I get 12 equal x plus c. When I'm adding those two equations, I get 20 equal 2x and no more c, right? Divide both sides by 2, x is 10. So if x is 10, I will replace it in one of these equations. Then I will get 24 equal 2 times 10 plus c. Gives you 24 equal 20 plus 2c. When I subtract 20, I get 4 equal to c, so my c should be 2. So I have x and c. So since we know x is speed of the boat in still water, your unit is going to be mile per hour. Same thing with the speed of current. That's going to be 2 miles per hour. And that's the information that we're looking for. So what I did again, give the variable, use the variable to create the information that I have from the given problem, and use that to create the equations, because I know that will be equations from the formula, right? So it will be rate times time. Rate times time gives you distance. And use the elimination method or substitution method to create the variable with one variable with the equation and solve for that one variable. Use substitutions to solve for the other, and that will be the solutions.